just coming in, if you haven't already gotten one, I've got practice lab exam copies down here. There are also some in the back, so feel free to discreetly slide back there, and maybe I won't notice that you haven't already gotten one. All right, so let's go through some details today. Right now we're kind of in an odd spot in terms of organic lab lecture that half of you have completed 20C, the other half haven't. So I'm going to just briefly touch on a couple of highlights of 20C for those of you who are doing it tomorrow. And then what we're going to do is focus on how do you do the data analysis, how do you figure out what's what, things like that when ultimately we put together all the data and go forward from next. All right, so a couple of things to take care of. First of all, okay, so hints and tips. So those of you who have not yet done 20C, those of you who have done 20C, lay back, take a 5-minute nap here. Okay, you'll be running this reaction in between 1 and either 0.2 gram scale for pig liver esterase or 0.3 for orange peel. Okay, so you can scale that up accordingly, okay, depending on how much you've got. Okay, you'll use your TLC to gauge the reaction progress. Yes, Matt? The amount of what?
We'll be using more enzymes, more reactors.
Yes. Yep. So yeah, depending on which one I think it's 10 mils per 100 milligrams for the orange peel, and is it 30 for the pig liver? And yeah, you scale that accordingly, depending on how much you're using. Yep. All right. You do TLC to gauge reaction progress. Keep in mind your lab prof might have slightly different methods for how to keep track of how long to run the reactions. Be sure to ask him or her before you get started if you're not 100% sure. Okay. Keep in mind that when you do that TLC of your reaction mixture, that solution is water, and so it takes a long time for water to evaporate off the plate. If you don't let it evaporate off the plate, you get these funny looking smudges, and your TLC might be incomprehensible. So keep that in mind. And then ultimately you want to run that against your 20A and 20B products. You've got 20A, 20B, and your reaction mixture. And so then you'll get a good feel for what you've got, whether your reaction is proceeding or not, if you have starting material left, and whatever else. Okay. All right. Okay, the workup, just as a quick little note. Okay, you're going to add 30 or 40 mils to extract the product. Okay, you're going to get an emulsion, especially if you're using the orange peel. It tends to happen. Long story short, remembering what's important here is drain off the aqueous layer, and then when you get that emulsion on the bottom, often with the orange peel, and in particular, it'll kind of stick to the sides. So if you get the aqueous layer all off, you can then pour the organic out the top and stick the emulsion in your set point. Okay? The key is that when you get the organic layer, that it does not contain water. That's really what's important. If you lose a little bit of product, no big deal. What we're really interested in is the ratio, okay, of the products that you get, not necessarily your yield. Okay? So just going to keep that in mind that when you work this up and separate it, you just want pure organic layer without aqueous layer in there. Okay? All right, and then as you've done before, we'll dry it into a tared flask. That saves yourself some steps. Okay, Rotovap, high vac, then you'll take an NMR and an ion. Okay? All right, so we've seen this all before. Many of you have already done this. Okay, so let's just kind of review. All right, so now we're just going to review what to expect at the end of the day when you've run this hydrolysis reaction. Okay, you've each got your whatever your diester is. We do the hydrolysis for whatever time set by your professor. Okay, whatever esterase you end up using. You got 4 possibilities that are going to come out of this thing. Okay, you can get no reaction whatsoever and get your 20B product back again. Okay, you can get the hydrolysis of both esters. Okay, so a very active enzyme under certain conditions can create both of them. Okay, and then you can also get either one side, hydrolysis of one side, or hydrolysis of the other. Okay, so there's 4 different possible products here. To kind of help you figure out which one is which, take note that you made 20A and you made 20B already, so you have direct things to compare those to. The starting material, okay, is right there. We don't often see much of that, but it is possible to get that. So we don't have you run it against a TLC, so you might not see it in TLC, but when you look at NMR, you may see this, so you can go ahead and get a literature spectrum of what that starting material looks like. Okay, and if none of those fit, then perhaps you've made this new compound up there. All right, and so now the question that I'll walk through now is how do you actually figure out which ones of these you have, right? keep in mind that these spectra that you already have in your possession will be very useful in figuring out what exactly the products are. Okay, and so you'll determine the amount of each species, right? All right, so here's when we get down to brass tacks. Interpreting your NMR. Okay, if you're really lucky or maybe really boring, you're going to get a spectrum that shows just one compound. Okay, then you can go ahead and interpret it just like you've interpreted these other ones for 20A and 20B. Okay, figure out what that is and go for it. Even then, it might be helpful to look back at your 20B and 20A products just to compare to make sure they're exactly the same. Okay, or you may get something that looks like this. There should be something in here that right off the bat tells you that you have a mixture of products. What is it? Okay, the aromatic region is really the place that we're going to focus on. Okay, so note down here in the aromatic region, okay, there's chloroform in there, of course, right there. We actually have a little bit of an OH peak in there. But if you kind of ignore those at the moment, we've got 2 sets here of doublets, and then 2 sets of doublets here. Okay, so that's really what we're going to focus on in determining how many species are present and what their relative amounts are. Okay, and of course, keep in mind that depending what the compound is and what your alkyl groups are, we have all these alkyl groups out here. And the added complication is that some of them are from this bigger species, some of them are from the smaller species. Okay? So it's easier just to look at the aromatic, figure out what you've got first, and then go ahead and match it up with all the alkyl peaks. Okay? You can go ahead and try to interpret these straight, and if you're lucky, you can do it, and if not, there's going to be overlaps in here, and it's going to be kind of messy. Okay? All right, so we're going to focus on the aromatic region right down here. Okay? Keep in mind, just as I mentioned, okay, each product is a pair of aromatic doublets. Okay, so you better see 2 for each species that's in there. And now we're going to zoom in on this region right here and take a look at that. Okay? All right, looking at it a little bit more closely. Okay, so this is just that region now between like 6 and 9. You can see a nice doublet here. They're approximately the same height. If you look at integration, they're not perfect. Why not? There's something else in there. Okay, so you can see it, you can look that there's like a funky kind of broad peak in there. It's probably an OH from one of these products. Okay, so keep in mind that that can mess with your integrations. So don't freak out if they're not exactly right. Okay, kind of look at it and see what else is there and see if there's any explanations. Okay, in contrast to that one, you notice these 2 that don't have impurities underneath them. Those are essentially perfect 1-to-1 ratio, what you'd expect. Okay, provided you don't get unlucky and have this sort of a thing underneath it. They should match up and have pretty much identical integration between the 2 big ones and 2 small ones. Okay? It is possible, if you're, again, whether you want to consider it lucky or unlucky, to have the same, to have a 50-50 ratio as well. Okay? So then you have to work a little bit harder to figure out what belongs to what. Okay? All right. So the ratio of these 2 compounds in this case, I'm not going to use this integration to determine a ratio because it's got that little bonus integration under it. So I'm going to look at these 2, and it's approximately 3.3 to 1. Okay, so I have 2 products in here, 2 aromatic containing products, a 3.3 to 1 ratio of the 2. Okay, but what compounds are they? This is where your 20A and 20B products are really going to come in handy. You want to overlay those things and find out which one is which and what matches. All right, this is where it's useful to kind of, again, you pull up your old spectrum, you can take a look and you can see where everything sits. Okay, so like, here's the 20A product right there. You got the propyl alkyl group. Okay, those 3 are right there. You can look at it, you can compare it. Okay, 20B, you can look like that. Okay, now we have that propyl that we started with. Now we got 2 extra bonus peaks from this ethyl. They're all over the place. So if you want to really quickly, you can go back and forth with these 2. See if you can notice what the differences are. Compare them. Again, the easiest thing is going to be to look at aromatics. Just ignore all of this other stuff for now and look at the aromatic region. Okay, so if we zoom in on the aromatic region, here's what I would recommend doing with these. Okay, you can do it actually on top spin, you can print them out, whatever works for you. Okay, and so this is the region I cut it off, but this is between 7 and 9 parts per million. Okay, so this is what 20A looks like. Okay, with those 2 peaks right there. If we line those up nicely, okay, we look at 20B. Okay, so this is the 20B product. Note that both of these shifted. Okay, and so now it should be pretty easy to tell. Do we have 20A, 20B? We line them all up nicely, and we look now in our final product, okay, and you'll see in 20C, this one matches perfectly with the big one. Okay, this one right here matches perfectly with the smaller one. Okay, this really doesn't leave a whole lot of doubt anymore, right? That the big peak down here is the 20A product, okay? Where this peak down here is the 20B product. What happens if you see another set of doublets that don't match either of these? Okay? By process of elimination, you know that the two of them are gone, right? And so now you have to basically look into, I would suggest looking into the literature for the starting material, for the para-hydroxybenzoic acid, to then compare what that is. One tip I will give you as well is sometimes you can get, like, your chloroform might not be exactly perfect, or whatever, your TMS, they might be off slightly. The gap between these two in terms of parts per million should be very, very, very close. Okay, so if you look at this one is at 7.95 parts per million. This is at 6.9. Okay, so even if your referencing is off and you couldn't find chloroform, or you accidentally referenced to like a grease peak instead of TMS or something like that, the distance between those sets of signals should be identical. Okay, so don't be worried if your numbers don't match up exactly right. You can slide the spectra from side to side and kind of match them up there when you're figuring out which one is which. All right. So any questions in terms of how to figure that out? Okay, so this will be useful when you look through your product mixtures and try to figure out how much of what you have in there. Okay, and again, okay, if I go back to what the spectrum here with the integrations on it, I use those two to compare. So I know that's 20B. I know that was 20A. Okay, and now I know that I have a 3.3 to 1 ratio of 20A to 20B. Depending on your product and exactly how they ask you to report these, you will probably be asked to report them as a percentage. Okay, so be sure you kind of normalize that for them and say, okay, it's 23% of the unreacted B. Okay, 77% of the hydrolyzed A. One thing I would note, unless they're absolutely huge, don't worry about impurities. Okay, so the vast majority of the impurities that you're going to see in these spectra are, okay, you got a little bit of ether left in there, you got a chloroform peak, a little bit of water. Okay, things that I really would not worry about in terms of skewing your yields and stuff. But if you see some giant peaks down there because you forgot to rotovap or something, then you probably want to take that into consideration for your yield. Okay? But with regard to the ratio of products, we're only interested in the ratio of the aromatic products. Okay? Does that make sense? So you simply want to report the ratio of any aromatic containing species that you get out of this hydrolysis. So any questions with that? How we get there? All right, and then what I always suggest is when you'll want to report your NMR data on the whole thing. Once you know how much 20A you have and how much 20B you have, then go back to the alkyl region with your 20A and 20B spectra, and then it's really easy to say, okay, this is from 20A, this is from 20B, these two overlap, and it's pretty straightforward. If you try to interpret those first, it can be really kind of a mess without having 20A and 20B already in hand. Okay? So that's just kind of the order of approach to doing this quickly and easily. All right. All right. Okay. And there you go. Use your old spectrum to assign LPs. Okay. So just what I mentioned. And like I said, as many as possible, because some of them will overlap most likely, especially if you've got some of the longer alpha chains. All right. So with that, depending on your lab prof, they'll have different ways of collecting the data, but we all sort of ask for the same thing. Okay, the basic information that's really easy: what alcohol did you use? What acid chloride did you use? Okay, which enzyme did you use? Okay, I think several of them are following my lead now. I often will send you like essentially a Google survey or something, where you go through and you just answer each of these in a Google form. Okay, and so approximate reaction time, percent of mass recovery. This is simply, okay, I got 0.25 grams of product out. I started with 0.3. Okay, so I got 5/6 of that. Just to report what your percent mass recovery is. Okay, so overall. And then this now is simply the percent of each of those 4 compounds that I mentioned. Okay, so the percent unreacted 20C, so that's the 20B product. Here's your 20A product. The ester acid, which is essentially the other one. And then the percent hydroxy acid, that's the starting material from 20A. Okay, so you simply report these 4 numbers as a ratio, or as a percentage. And there you go, that's all you need to do. Ultimately, then your classmates will fill in the rest of the table for each of their results, and then hopefully, sometime in the not too distant future, you're going to have a whole spreadsheet full of all the information with everybody's results on it. So, any questions with this so far? And your lab prof will presumably give you a deadline that you have to have this information submitted to them by such and such a date. Okay. That is up to them. All right. So now for that final report, what do you have to put together here? All right, so for 20C, what you'll want to do is do a mini conclusion of just your 20C. So hopefully you got a mini conclusion for A and a mini conclusion for B as we've been going along. So again, just that little quick little paragraph. Okay. This one, 20C, is going to be a little bit bigger because this conclusion is the part where you actually analyze your own data. Okay. This is your time to put in your NMR and IR spectra with their data tables. Okay, so this, essentially think about this part, is just analyzing your data. Okay. The data tables from both of those. Some hints and tips on how did you assign what's what. Okay, you know, how did you figure out what your ratio of products was, things like that. That goes into your 20C, like essentially your personal mini conclusion. Okay, so once you've got that on your own, then you want to look at the entire class's data. Okay, so kind of think about it as in two steps. Okay, so you want to analyze like the yield and selectivity data. Are there trends? Okay, does orange peel go really, really fast and the pig liver esterase go very, very slow? Do the methyl esters all cleave but the propyl esters don't? Those sorts of things. Okay, again, you're looking at all the data and trying to put things together that way. Okay, so comparison of enzymes, as I just mentioned, comparisons of groups on R and R prime. Okay, it's possible to see that methyl groups on R prime cleave very easily, but methyl groups on R don't. Whatever it happens to be. Okay, kind of the overall picture of the reactivity in that sense. Which things went fast, which things went slow. And then finally, that, you know, if we think about that whole hypothetical situation, which conditions are the best to give you that monoester? Yeah, well, I put that in there because there's a couple of lab profs who really, really want the answer to that question at the end of the report. Okay, which is the ones that will give you that hypothetical, you know, desired ester or not. I have to admit, when I'm grading these reports, I forget about the whole hypothetical situation and just want the analysis of the data. So, but that's to, you know, each prof is their own. So, all right, questions on that? And again, this is available, you know, online. Be sure you ask your lab prof for specifics. Okay, so they might want something a little extra, or this might be too much, or whatever else. Everybody's a little bit different, but kind of, you know, ask a little bit if there's any specific information that you need that they're going to be looking for. All right, questions on that? Excellent. All right, that final report is due a week from Friday. Okay, so I'll send you some other reminders between here and there. But keep that in mind. That'll be the last day right there. Okay, as far as the schedule goes, just as to kind of keep in mind, tomorrow, I guess we got 2 labs lined up to finish up 20C. Okay. On Thursday, CIS, everything is closed down. Okay, so don't try to come for open lab or anything next week, or on Thursday. Okay, things are going to be closed down. Go hit some of those talks and see what's going on. Okay, open lab will be as normal on Wednesday and Friday, or approximately as normal, for any of your last minute weighing and, you know, IRing needs. And then next week, the general plan is there'll be a little bit of discussion of the data at the beginning of class. That's especially for the Tuesday sections. Thursday, you might want to check with your lab prof because that does not give you a lot of time to then turn around a report that's due the next day. Okay. But you'll be doing a little bit of lab discussion, and then after that, there'll be checkout for those of you, you know, you poor souls who are only taking A and not exploring the wonderful opportunities that are available in 256B. Okay. Then you'll be checking out of your drawer. The folks who are doing 256B then will head on to the library to do some literature information and stuff like that. So, all right. So that's it in a nutshell. Any questions on things?
When do we take the lab?
So the lab final is a week from today in this room. Okay, so for those of you who are at home, you know, watching this, you actually may address them directly. So for those of you at home watching this, be sure you're here next Friday, 4 o'clock. Okay, and if you can't be here, you better let me know ASAP. All right. So for the rest of you, you're here. Come just like you are. Lab exam 4 o'clock will be split between these 2 classrooms. Okay. I gotta make sure that they caught that, right? All right, be sure you're here. Okay, I'll send you out a reminder, but ultimately what you will need is a calculator with basic, you know, addition and multiplication and division functions. Okay, and a pencil and an eraser. That's going to be pretty much it. If there's anything else, I will send you out a note as a reminder. Okay. All right. Anything else? Okay, one other thing, those of you who if you happen to still be contemplating 256A and 256B, one way or the other, you're signed up and you're not sure if you want to, or it sounds like such an awesome opportunity that you can't pass it up and you want in, okay, which is the wiser decision. But either way, okay, let me know, okay? Feel free if you know, either way I can email you permission to add and things like that. So just let me know if you want to discuss it and kind of feel out what it's going to be like. Feel free to swing by my office or let me know and we can talk about it a little bit. So there's, I still have a little bit of time to do that. Just keep in mind that essentially if you miss that library section discussion next week, then it's hard to get back in to 256B to catch up. So that's like the last chance for the train to leave the station. So with that, okay, questions at all with 256AB? Questions with the lab this week? All right, so with that, thinking about the lab exam for next week, everybody has got a lab exam now, a practice lab exam. All right, I hope. If you haven't, so for those of you again at home, it's available on the Moodle site. Okay, so you feel free to grab a blank copy from there. The key for this is available, I think I set it for like Wednesday evening or something like that, that it will then pop up on the Moodle site as well. Okay, so that is available. A couple of things you'll note right away. I heard your dismay when people opened it, is this is not purely multiple choice like it was in the first semester. Okay, some of you are cheering, some of you are sad. Okay, there's a mixture here of multiple choice, short answer. There'll be some NMR interpretation. Or overall data interpretation, the whole shebang. There's a little bit of everything in there. Okay, so this is going to be very, very similar to the general structure of what you're going to see. Okay, some hints and tips on what to look for. Okay, one thing I will tell you, the focus is all going to be on this semester, so we're not going to pull out, you know, what was the second reagent that you added in experiment 8? Okay, it's not going to. It's all going to be this semester. Okay, the concepts in this semester, obviously, the first couple, NMR. Okay, keep in mind both experiment 18 and 16. Okay, so that worksheet about predicting chemical shifts and stuff like that, you should be able to know how to do that. Basic coupling and things like that are going to be on there. Okay, the Wittig reaction, okay, and the wonders of the column chromatography and that data analysis, and then experiments 20, A, B, and C. Okay, some general tips on how to go about studying for these things. Is to be familiar with the reactions, be familiar with the experiments and what was going on in each one. Okay, be able to chemically draw out what transformations occurred in each one. What I find helpful, I think, to kind of get a feel for what's going on in each experiment is your flow charts. Hopefully you've got very nice flow charts, okay, that tell you what happens at each stage, why you did each step of those within those flow charts. That can be really, really helpful. If you understand that flow chart and know what's going on at each step and why you did it, that's money. Okay, you're pretty much there. Okay. Some of the other things that can be useful is once in a while we'll go into a little bit of theory in terms of why something works the way it does, how would it work better, how would it, you know, what would, you know, detract from the overall effectiveness, okay, things like that as well. The basics of NMR, we're not going to go into too much theory on how an NMR works and things like that, but interpretation of NMR will be in there. Okay, so with that as kind of a little bit of an intro, think if there's anything else to tell you right off the bat. I think that's pretty much it. Okay. So does anybody have any questions on it, just in terms of overview? Otherwise, what we'll do is we'll spend a little time if people have specific questions on things that are in this. I know some of you have had this for a while. Others have just gotten their copy now. Okay. Any overall questions about the mechanics, the schedule, the technicalities of what's going on?
Yeah. You said it's good to know the flow chart. Do we need to like memorize what's happening, or mostly just if like you tell us what happened, why we did it?
Yeah. So in terms of knowing the flow chart, don't feel like you need to memorize. So you know, in the third step of the workup of 20C, what reagent did you use? You know, who knows, right? But to say, you know, in the workup of 20B, we use a sodium hydroxide wash. Why? Okay, that can be useful. Okay. And I would say most of the time those will probably be of the multiple choice variety, but something like that. But you don't have to. So I would say have a good understanding of the reactions and the processes, but don't feel like you need to memorize exactly what went on and exactly how much of each reagent and stuff like that. No. Okay. But the general idea of what happened in each separation, okay, that's a great thing to know. Yeah, Matt.
Should we bring a ruler just to the exam?
I will look into that on whether you will need it or not. Okay, I will send you a note on that. In the past, like for example, in this one, there is one where you need to measure coupling constants. Some years we do that, some years we don't. Okay, it sort of depends on who decides to contribute what to the exam. So, all right. But I will let you know. At this point, plan on bringing a calculator, there. You know, we often have percent yield questions on there, so bring a calculator and bring a pencil and eraser. Or for those of you who are truly bold, you can do it in pen, but whatever. It takes a special breed, whether that, plus or minus, we'll see. Okay? But those two things right now, I'll let you know if there's anything else. Okay. All right, any other general kind of technical type questions? Yeah, Morgan.
Will we only get like the 50 minutes for the?
That is the plan, yes. Yep. Might be a little bit flexible there at the end, but yeah, we won't give you like the hour and a half. So hopefully we'll be able to keep this down to a 50-minute exam. Okay? Any other questions? All right, so at this point what I would say is if you have questions on certain problems in here that you've worked through and kind of have specific questions about, feel free to shout them out. I can work through them. Otherwise, if you want to take advantage of the extra 25 minutes you have right now and go and do something else, you can feel free to do that. So, all right. So if people want to take off, go for it. You want to hang out and see some questions, let me know. We'll give people a minute or two to kind of figure out what they're going to do. There you go. Good for you. Good for you.